Hello everyone, this is Dr. D. Rajalakshmi. In today's session, we are going to see how to handle deadlocks using Maekawa's algorithm. Maekawa's algorithm is a quorum-based mutual exclusion algorithms. So in the case of quorum-based mutual exclusion algorithm, a site does not request permission from all other sites but only from a subset of the sites. So Maekawa's algorithm is working in 3 stages. The first stage, requesting the critical section. A site SI or S1 requests access to control section by sending request messages to all sites in its request set. Its request set is containing 2 sites S2 and S3. So it is sending a request message to S2 and S3. When the site S2 or SJ receives the request message, it sends a reply message to S1 provided it hasn't sent a reply message to a site since its receipt of the last release message. Otherwise, it queues up the request for later consideration. Now, the next stage is executing the critical section. The site S1 executes the critical section only after it has received a reply message from every site in its request set Ri. Its request set Ri is containing S2 and S3. So, the site S1 is entering its critical section after receiving reply message from S2 and S3. The third stage is releasing the critical section. After execution of the critical section is over, site S1, it sends a release message to every site in its request set. That is, it is sending release message to S2 and S3. In this way, Maekawa's algorithm is working. Actually, Maekawa's algorithm can cause deadlock because a site is exclusively locked by other sites and requests are not prioritized by their timestamps. Assume 3 sites SI, SJ and SK simultaneously invoke mutual exclusion. Suppose Ri intersection Rj is equal to Sij and Rj intersection Rk is equal to Sjk and Rk intersection Ri is equal to Ski. Consider the following scenarios. Sij has been locked by Si, forcing Sj to wait at Sij. Sjk has been locked by Sj, forcing Sk to wait at Sjk. Ski has been locked by Sk, forcing Si to wait at Ski. This state represents a deadlock involving sites Si, Sj and Sk. Maekawa's algorithm handles deadlocks by requiring a site to yield a lock if the timestamp of its request is larger than the timestamp of some other request waiting for the same lock. A site suspects a deadlock whenever a higher priority request arrives and waits at a site because the site has sent a reply message to a lower priority request. Deadlock handling requires 3 types of messages. They are failed message, inquire message and yield message. Failed message from site Si to Sj indicates that Si cannot grant Sj's request because it has currently granted permission to a site with a higher priority request. An inquire message from Si to Sj indicates that Si would like to find out from Sj if it has succeeded in locking all the sites in its request set. A yield message from site Si to Sj indicates that Si is returning the permission to Sj to yield a higher priority request at Sj. Maekawa's algorithm handled deadlocks as follows. When a request from site Si blocks at site Sj because Sj has currently granted permission to site Sk. Here Sj has currently granted permission by sending this reply message to Sk. Then Sj sends a failed message to Si if SI's request has lower priority, otherwise SJ sends inquire message to site SK. In response to an inquire message from site SJ, site SK sends, this is what is our site SK, the site SK sends a yield message to SJ provided SK has received a failed message from a site in its request set, or if it sent a yield to any of the sites but has not received a new grant from it. In response to a yield of K message from site SK, site SJ assumes that if it has been released by SK, places a request of SK at appropriate location in a request queue and sends a grant to the top request sites in the queue. Maekawa's algorithm requires extra messages to handle deadlocks. In this way, deadlock is handled by Maekawa's algorithm. Thank you.